Hello guys, let us start discussion of this JEE Advance 2022 paper 1 3D problem in which they have given two planes P1, P2 and saying which of the following straight lines can be edge of some tetrahedron whose two faces lie on P1 and P2. Now, this is how a tetrahedron looks like. It's a 3D figure in which we have a base triangle and fourth vertex which will be out of the plane, and we join that with all the remaining three vertices, we get this 3D figure tetrahedron. If I break into two parts, this base triangle we'll refer to as ABC. Let us say this lies in P1, and the side triangle ABD, let us say this is a part of P2. Total there are six edges: 1, 2, 3, 4, 5, 6. You see, three of them are part of P1. P2 will have one common with P1 and two more edges. So in total, five edges they will cover, only one edge, CD, will be left. Now, how do we check which of the following edge could be some edge of tetrahedron? Which of the following lines could be an edge of tetrahedron? First of all, we just write the DRs of normal of the planes and DRs of the line. And first thing I'll do is I'll find the line of intersection of P1, P2. Because you can say line of intersection of P1, P2 must be an edge. So maybe one of the option would be line of intersection directly. What is the best way to find line of intersection? You see, line of intersection is nothing but a line found by any two common points of plane P1 and P2. So to find line of intersection, just find two points which satisfy both P1 and P2. You can see 0, 0, 5 will satisfy both of them, and 0, 4, 0 will satisfy both of them. If I put x as 0, z as 0, and y as 4, it will satisfy both of them. So if you got 2 points, you can join them to make the line. And drs you can find by simply x2 minus x1, y2 minus y1, z2 minus z1. We get drs to be 0, 4, minus 5. The given four lines are, their drs are 0, 0, 5, minus 5, 2, 3, minus 2, 5, 4, 1, minus 2, 3. None of them is parallel to this line. That means none of the line is line of intersection. So that is confirmed that none of these following four lines are line of intersection. Next case. Now, a line could be an edge of tetrahedron if it lies one of the plane P1 or P2. You can see there are two more lines here in P1, two more lines in P2. Let us say if any of the following four lines lie in any of the plane. To check it quickly, you just need to see first of all if the line is parallel to plane or not. A line will lie in plane if it is parallel to plane and its passing point satisfy the plane also. So if we check if the line is parallel to plane, you can just dot the DRs of line with with the DRs of normal of the plane. If the dot is 0, we can say it will be parallel to the plane. So you see L1, L2, L3, L4, none of them will be parallel to P1. Now L1, L2, L3 will also be not parallel to P2, but L4 when you dot with P2, you see you get minus 2, minus 10, plus 12, you get 0. That means L4 is parallel to P2. Now to see if it is lying in the plane or not, you see the passing point of L4. Passing point of L4 is just 0, 4, 0. You see that is the point in their line of intersection also. So L4 is parallel to plane and its passing point of L4 is in the plane also. So we can say L4 lies in P2. Now if a line lies in P2, that doesn't guarantee it could be a edge of tetrahedron, because what if it is parallel to this pink line? If the line lying in P2 is parallel to AB, then it cannot be edge of tetrahedron. It must intersect this AB. And you can clearly see that the AB, the line of intersection, which I'm referring to as L5, is passing through 0, 4, 0. And you see the L4 also is passing through 0, 4, 0. So they are intersecting. So we can say L4 must be then edge of tetrahedron. Okay, so this D option will be correct. Now what we get that L1, L2, L3, none of them are parallel to the planes. So they are not qualified for these lines. So they could only be CD. If only they are some edge of tetrahedron, they could be CD only. That edge which lies in neither of the plane. Now that edge which lies in neither of the plane, it must be skew with AB then. It should not be parallel to AB and it should not intersect AB. You can see here for this tetrahedron, these two opposite edges are always skew lines. So now we have to see out of L1, L2, L3, which of these lines is skew with the line of intersection. Line of intersection we refer to as L5, passing point 005, 004, and DRs of line are 04, -5. You can see none of L1, L2, L3 is parallel to this. So if it is not parallel, we just have to make sure they're not intersecting also. One thing can clearly see L3. You see L3 is passing through 040 again. That means L3 is intersecting L5. L3 intersect L5 at 040. That means it is not skew line. These are not skew lines then. So L3 is cannot be an edge of tetrahedron. So only we have to check for L1 and L2. So L1, if I check here, L1 is not parallel to L5. So if it is not parallel, then how do we check if it is they are skew or not? I hope you know the formula. It is that box E2 minus A1 B1 B2. If this box is non-zero, we say they are skew lines. So A2 minus A1 is basically their point of passing points you have to take. So L1 passing point is 1, 1, 1. This passing point is 0, 0, 5. So 1 minus 0, 1 minus 0, 1 minus 5. Then B1, B2 are they just the DR. So 0, 0, 5 and 0, 4 minus 5. When you find this det, box is basically det only. It will be non-zero. So L1, L2 are skew lines. So L1 can also be a edge of tetrahedron. Similarly, we check for L2. L2, you see the passing point is 600 and DRs are -523. So 600 here is 005. So 6 minus 0, 0 minus 0, 0 minus 5, DRs -523 of L2 and 04 minus 5 of L3. When you find the det, it will again be non-zero. So L2 and L5 are also skew. That means L2 can also be the edge of tetrahedron. So finally, what we get is A, B, and D. These lines can be edge of tetrahedron. C option, the L3 cannot be edge of tetrahedron because it does not lie in any of the plane and it is intersecting the edge AB. I hope it is clear, guys.